to the Ramsey Library Brown Bag series. I'm Gene Hyde, head of special collections and host of the series. And today we're very excited to have Allison Ormsby with us and Murthy Muthukrishnan with us. So if y'all, go ahead.
Great. Thank you, Gene. First of all, I'd like to ask everyone to mute if you're not currently muted. That would be great. As Gene said, I'm Allison Ormsby. I'm the interim co-director of sustainability for UNC Asheville, and I'm also a lecturer in environmental studies. And I'll be presenting first, and then Murthy Muthukrishnan will be presenting along with Corey and Leaf, two of our students. So it's going to be a team effort today. So I'll start with the carbon commitment and our climate action plan, and then Murthy will continue with solar feasibility and a little bit about microgrids. So thank you for taking time out of your busy days to be on yet another Zoom and join us for lunch. Okay, so let me start by defining a few terms. First, carbon neutrality. So we will achieve carbon neutrality, and we've set a campus goal of 2050 for our carbon neutral date. We will have achieved that when we balance our greenhouse gas emissions with reductions, also renewable energy installation, and offsets. And then once we have completely balanced that, we will have achieved neutrality. A greenhouse gas inventory is our measure annually, ideally, of our greenhouse gas emissions. So it's an inventory, and we can use this inventory to measure how we're going to reduce our emissions and to track our progress. And this is required by the carbon commitment, which I'll explain. And then finally, our climate action plan, or CAP. The climate action plan outlines our proposed action items to reduce our greenhouse gas emissions for the campus. And as you can see in the triangle at the lower right corner, what we're trying to do is first behavior change and efficiency to lower our energy use without technology, just by behavior and then things like insulation and changing light bulbs, things like that. And then we'll use technology to increase our efficiency. And then we will also change our energy intensity and switch to low carbon energy sources like renewables. And finally, offsets are our last resort, right? We're not really pushing for using renewable energy credits, just by the way. Okay, so what is the carbon commitment? You may be familiar with this, but just to review, this is a nationwide initiative, and it's managed by Second Nature, which is a Boston-based organization. It started in 2007, so it's been around for quite some time, and it's colleges and universities take a pledge to become carbon neutral. The colleges and universities set their own carbon neutrality goal date. So in some ways, it's like the Paris Agreement. We set our own targets. But by setting a target, a carbon neutral target, that forces us to take actions and to make a climate action plan so we know how we're going to achieve that carbon neutrality. So it is a voluntary pledge, and it is signed by the head of the university, in our case, our chancellor. We commit to doing a greenhouse gas inventory annually through this pledge. And at the moment, we have a partially complete inventory. We are required to submit progress updates to Second Nature every year. And we're also required to make curriculum connections. And I see that Jake Hagedorn is on the call, and we are doing some collaborations with his class right now and with one of my classes. So you can see the timeline. First, the chancellor signs, and we went through an 18-month process to try to advocate for the chancellor to sign this. Then within 2 months of signing, we have to set up an institutional internal structure to guide the climate action plan, which for us at UNC Asheville is our Sustainability Council, which already existed. Within 1 year of signing, we need to complete our greenhouse gas inventory. And we've been doing a partial inventory since 2015. So it's not that we're starting from scratch. I want to acknowledge the good work we've already done. Then we look for reductions options and do our first report to Second Nature. And then within 2 years, we set our carbon neutral date, although we already set that. And we have to write the climate action plan and have it approved by the Sustainability Council. Figure out how we're going to track our progress and figure out curriculum connections. So that's the timeline. So just a little background, some other system schools had already signed this. So there are 17 schools in the UNC system. 5 had already signed, and you can see going back to UNC Chapel Hill signed in the first year. But more recently, App State signed in 2016, and now we've signed. So there are 6 out of the 17 schools have signed. But if we look at other North Carolina institutions, and I'll give a shout out to Warren Wilson. I see Dave Ellums on the call. They signed back in 2011. So there's several other institutions in North Carolina. So we are joining our peers who have already signed this carbon commitment. There's also something called the climate commitment, which we did not sign. That also requires a campus resilience plan. How would we become climate resilient? So that's another extra step, which we could think about in a future year. All right, I just want to say how this aligns with the UNC Asheville and UNC system goals. And this was some of the persuasion that we used to get the chancellor to sign this commitment. So first of all, the UNC system has a policy that says for all universities in the UNC system, that university shall develop a plan to become carbon neutral as soon as practicable and by 2050 at the latest. So by us picking the 2050 carbon neutral date, we are now in alignment with the UNC system policy that already existed. Also, sustainability is one of UNC Asheville's core values. So this really aligns with our core values. So we have a commitment to innovation, a willingness to change. We have a commitment to sustainability, support of the environment. And we have a commitment to educating students about sustainability. We have a strong environmental studies major. We have a sustainability certificate program. And we integrate environmental literacy throughout the curriculum, including in our humanities program and lots of other places. So we're already doing this, but by signing the carbon commitment, we affirm these values. I also want to note the connections to initiatives at the city, county, and state level, and even global level. So I'm sure you're all aware that Asheville has a clean energy pledge. The city of Asheville has pledged to go 100% renewable on city buildings by 2030. So for example, here's the bus station downtown that already has solar on it. But the city has pledged to go 100% renewable on all city-owned buildings, including things like fire stations, schools, City Hall. Then at the county level, the county has pledged to go 100% renewable by 2042. That includes everything in the county, not just county-owned buildings. So that's an ambitious goal. And I will give a little shout out. Buncombe County has been helping us with some solar feasibility studies on our campus. So in helping them to reach their 100% renewable goal, they are helping with phased in solar on certain places around the county. And then our governor signed Executive Order 80 some time ago, and that pledges the state to reduce greenhouse gas emissions and increase the use of zero emission vehicles. And through that executive order, then that opens up incentives to implement these initiatives. So we're in line with all of these ongoing initiatives at multiple layers. And then finally, at the international level, the Intergovernmental Panel on Climate Change, as you know, has issued a series of reports that pick 2050 as the date by which it is imperative that we limit our temperature reductions to 1.5 degrees, ideally, to limit non-recoverable damage to the planet from climate change. So we are in alignment with all of this. I'm going to go quickly through this, but I just want to highlight some benefits of signing the carbon commitment. We have already signed, so we're getting these benefits now. So we are committed to tracking our greenhouse gas emissions to inform our goals on campus, our sustainability goals. We're attracting prospective students and reflecting the values of current students. There are lots of research and co-curricular opportunities. We meet that UNC system requirement. There's also new funding opportunities that this is opening up, so that's exciting. And we're preparing the campus for climate change. We're making the campus more resilient to climate disasters, and we're anticipating the rising costs of fossil fuels. So we're going to get ahead of that and avoid those future costs. There are some obstacles, and we need to be honest about that. So we want to make sure this is sincere, that it's not an act of greenwashing. We want to really implement it, not just commit and then not have action. There is an additional administrative burden. We did not add any new staff or faculty positions, so it's added to our existing workload. The financial cost just for maintenance is about $3,000 a year. That is going to Second Nature and SciMap, which is the reporting tool for the carbon commitment, which I'll explain. It requires campus-wide participation, which we kind of have, but we're a little disjointed at the moment. So it's forcing us to collaborate across departments. We have committed to this in perpetuity. So at least for the next 30 years, we're going to be working on this. And like I said, we need to ensure that the climate action plan is put into practice. So hooray, the chancellor signed the commitment on March 30th, 2021. So we are now officially a signatory. Right now, we are wrapping up the third version of the draft of the climate action plan, and we're going to present it to the Campus Sustainability Council in about 10 days. And we're going to ask them for feedback and eventual approval. And I already reviewed this timeline. So basically by March of 2022, which is coming up soon, we'll submit our first greenhouse gas inventory to Second Nature. And this is from the Carbon Commitment website, but it shows kind of that same timeline. And our climate action plan is going to be updated every 5 years. So it's not that the action plan we approve this year or next year is set in stone. We're going to be adaptive because new opportunities will arise, grants, technologies. So we'll update it every 5 years. And I will say, you're welcome to put some questions in the chat as we're talking, because we'll have a little break after my talk for questions, and then we'll go on to the next talk. Okay, so I wanted to get into greenhouse gas scope emission categories, just so we can be clear on this. Because sometimes when we talk about greenhouse gas emissions, we just think about the power bill. That is not the only source of our emissions. Scope 1 are our stationary fuels. These are fuels that are produced or used on campus. If we had a diesel generator or a gas station on campus, that would count. Propane that we use, say, in fireplaces on campus, any propane tanks, that counts. Natural gas and fertilizers used on our athletic fields. Those are Scope 1 emissions. The largest is our Scope 2, which is the electricity that we purchase from Duke Energy. So that one's really easy to track. We're supposed to be tracking all of these, by the way. And then Scope 3 is the indirect emissions. So Scope 1 is direct and Scope 3 is indirect. So those include things like study abroad, emissions associated with UNCA-sponsored and led travel abroad. Solid waste, all of our waste sent to the landfill, also all of our composting and recyclables, and our wastewater. We track that at the moment, the solid waste and the wastewater. Other things that are harder to track, commuting, our campus fleet, and the impacts of our food use on campus, which we are at the moment not thoroughly tracking. I worked with a student in the summer of 2020 to look at our greenhouse gas emissions, and she developed this graph. So you can see Scope 2, our purchased energy, is definitely the largest piece. Scope 1, propane and fertilizers is small, and Scope 3 looks small, but that's because we have incomplete data at the moment. So we will be refining that data, and this graph will change. But what you can see is that we're fairly even, kind of plateaued. And in order to get to carbon neutrality, all of those lines need to decline to zero or be offset. So that's going to be an interesting challenge. Okay, now I want to go through the climate action plan, just a high-level overview of what we've decided is to set goals by decade. So we have 3 decades. And I'm going to highlight 3 things for each of the decade, or 1 thing for each of the decades: bikes, our fleet, and green roof and living machine. So here's a picture of a green roof, and there's a company in Asheville called Living Roofs that works on green roofs, and we've had a student do research with them last summer. So that's an interesting thing to look at for our campus. So let's start with our short term. So within this decade, 2020 to 2030, there's a few things we can focus on: bikes, solar, and compost. We have a bike shop on campus. We have some bike lanes. But this number one is how we could improve our biking infrastructure and reduce our commuting to campus. So we could expand our bike lanes. There's some gaps on campus. We have some bike lanes, but then they kind of stop. We have purchased one e-bike for our bike shop demo fleet, but we could purchase more e-bikes. We would like to promote Walk or Bike Wednesdays. We would like to become certified as a bike-friendly campus. This is a nationwide initiative, and we're currently not certified. We would like to install additional bike racks on campus, and we can easily conduct information campaigns about biking resources. We are in the process of installing solar on one more building, the Ali Reuter Center, and that should be completed next year. But we would like to install solar on many more campus buildings when funding becomes available. And we would like to launch an on-campus compost processing program. Right now, we do compost, but our compost is collected by Atlas Organics, which is based in Greenville, South Carolina. So that's a large carbon footprint. And if we compost it on campus, we would completely reduce that, and we could produce great compost material that we could use on our grounds or sell. And it would be a great research opportunity for students. So that's 2020 to 2030. All right, the second decade, 2030 to 2040, where we would hopefully focus on our fleet and solar and a microgrid. So we would like that each department that owns vehicles tracks and reports their annual fleet emissions. Right now, about 5 or 6 different departments on campus have vehicles, and it's not tracked in a centralized way. It's actually quite disorganized at the moment. So, and we would also by 2040 have our fleet be 75% electric with improved campus infrastructure, including at least 10 additional EV charging stations. We're putting in new ones that should be in by spring, and that will bring us to 8 charging stations, but we'd like to have a lot more. We would like to install solar on additional buildings. This is part of every deck. Oh, good idea, Kelly. Future bike rack should be designed with e-bike charging stations. Whoa, that's a great idea. Okay, we want to install solar on more buildings, and you're going to hear about the solar feasibility study next with microgrid battery storage. And we'd like to convert one of our satellite properties to be off-grid or at least have solar. And there's a proposal in the master plan to have an off-grid sustainability demonstration center on campus by the back entrance, if you know where parking lot P1 is. So that would have a demonstration net zero tiny home and information kiosk about sustainability. That is, as of right now, unfunded. All right, let's go to the final decade, 2040 to 2050. So some things we could do is a green roofs or walls, a living machine, and of course, more solar. So I have a slide about green roofs if you're unfamiliar, or vegetative walls, but we'd like to install those where feasible to increase energy efficiency of existing and new buildings. It'd be great if they were planned into all new construction on campus, either green roofs and or solar. And I will mention that Zeiss, our science building, chemistry and biology, it was designed to have a greenhouse on the roof, but that was value engineered out at the last minute. So Zeiss would be a good candidate for this first, I would say. And it could be a great research opportunity. Also, it'd be great if we could create a living machine on campus, and I have a slide about that. At this stage, we could install solar parking canopy on parking lots like P1 or the Edgewood lot. And we could plant a carbon sink forest to offset study abroad emissions and travel for faculty, staff, and students attending conferences, which we also need to track that. And at the moment, we're not tracking that. Okay, so let me just get into a little bit more detail. So these are more aspirational and cost a lot of money, but would be great for grant opportunities or donor opportunities. So a living machine is basically a constructed wetland, and it provides bioremediation or water treatment using wetland plants. So here's an example of one in the top right. 3 colleges that I know of have them already: Oberlin in Ohio, Furman right near us in South Carolina, and Penn State. So these wetlands take wastewater, usually gray water. So that would be the water from a sink or a washing machine, dishwasher, clothes washer, and treats them with the wetland plants. And then that water can be used on campus. So again, this is a closed loop water system. We wouldn't have to send our wastewater to the water treatment plant, and that would lower our water carbon footprint. And we could use that treated water on irrigation. These living machines are used around the world already a lot, and they're starting to be used on college campuses more. And then green roofs. So we do have a green roof on Whitesides Hall at the moment, if you want to go see one. So green roofs provide carbon dioxide storage. They trap stormwater runoff. Of course, they provide habitat for pollinators and other creatures. You could produce food on a roof like in this picture, but I'm not sure we would do that on campus, but you could. They insulate the building, so reduce the heating and cooling costs of the building significantly. And you can visit one at Whitesides. So if you're on campus, you can go over to Whitesides. When you walk in the main door and you walk through, you're on a patio, but actually you're on a green roof on top of the basement level. So it's a really cool design, I would say. Okay, so that is all for my presentation. Here's my email address if you have any questions or suggestions. The Climate Action Plan has many more ideas than this, but I just want to give a high level view. So the e-bike suggestion was already a great one. So let's just open up for a moment for a couple of questions here. Oh boy, who said that? Keith. Okay, so there's a lot of microgrid people on this call, so we got like high level knowledge going on. But there's a thing with metering, net metering versus behind the meter. And right now, Duke Energy has a 1 megawatt limit on our solar, but that's about to change. So we would, if we put things behind the meter, then we would use them immediately on campus and not have to send it to Duke and then buy it back. So yes, we're on that. Okay, Don has a question.
I was wondering if you'd made any estimates about how much energy or carbon the actions proposed will actually achieve, because I don't really see it.
Oh, Don. I am looking for a volunteer. I want to give a little shout out to Corey McVeigh, who's on the call and is presenting next, who is our climate analyst. So we have a student position in the Office of Sustainability for a climate analyst. And Corey and I are trying to make that graph right now, Don. Point well taken. So what we want, we have that graph of emissions, and we want to create a wedge graph showing for each of these actions, what is the slice of the wedge for the offset that they'll provide, or how much are they going to reduce our demand? And Don is right. The actions we have so far will probably not get us to carbon neutrality. Even with, so this is a good segue to the next presentation, which is on solar feasibility. And Corey and Leaf last summer, as a student research project, figured out how much, if we put solar on quite a few buildings, what percentage of carbon offset would we achieve? And it's not 100%. So I would love some help with the graphing to make that graph. Corey and I are struggling with that at the moment. But we want to create that graph. So yes, we need some bigger ticket items. And some great funders.
I mentioned I gave a talk at App State, I think it's 2 years ago now, and asked them about their climate commitment. And this was to the Sustainability Office and facilities. And they pretty much said they're not going to make it.
Well, okay, not to digress too much, but when we talked about the carbon neutrality target date, 2050 feels far away, right? For some, not for the oldies, but for the students, it feels far away, which is why we're picking these decades, first of all. So we have interim targets, that's good. But honestly, we need until 2050 to get this done. And I think it's a very realistic target date. So other schools have had more ambitious, but what they're ending up doing is buying a lot of RECs. And I don't think that's the answer, personally. Yes, efficiency is really key. And I want to actually thank Dan Croissant, who is our energy manager for the campus. And he has been working hard with campus operations to really implement energy efficiency. And we have one of the best energy efficiencies of any of the UNC system campuses. So we've already lowered our energy use intensity per building square foot. So we've done some of that. We've done some of the low-hanging fruit. Now we need to get into the bigger ticket items. And we're looking for funding opportunities. Let me just say that one more time. Okay, in the interest of time, I want to shift to our next talk, which Murthy is going to share screen on. So I welcome more questions. Put them in the chat as we go along.
Okay. Good afternoon, everyone. So I'm continuing with the presentation. So we have, let me go to the first page, sorry. So this is the presentation that we are going to make on the project we did over the summer. Two of the students, Corey and Leaf, they worked on this project. It's basically to study the feasibility of solar energy generation on our campus. So I will cover up first few slides, and then I'll pass it on to Corey and Leaf. We'll cover the rest of the details. And again, this is a lot of work. We won't be able to cover all the details in this presentation. If anybody is interested, we'll be able to arrange for another meeting and then go over that. Allison and I, we advised this project over the summer. So where did we do this project? So basically, we wanted to support the campus sustainability goals and also help with the climate action plan. And as Allison mentioned, the purchased energy from Duke Energy and the gas is the highest energy consumption on campus. So we want to help reduce that, probably make it zero. And we will cover why solar energy, why can't we use wind energy or some other form of energy. And again, we have a couple of slides. We won't be able to go to the details, but solar energy is the one we picked. And the students will be presenting their results of their study. And we also propose a microgrid instead of just installing the solar panels on the buildings and the parking lot. We wanted to propose a microgrid, and we will explain why. And we have a lot more work to be done. It's only about 25% done. So we'll continue the work with the same students, and we have got some new students to do the work. All right. So how do we support the sustainability goals? Already, we have the lowest energy consumption of all the UNC campuses, thanks to Dan Croissant and the facility staff. But there are opportunities to reduce the energy consumptions further. And we can generate our own electricity. Right now, only thing that we do is diesel generators, and they consume a lot of fuel. We want to do that with solar photovoltaics. And we don't have any batteries right now. We want to have local batteries so that we can store the energy when the energy charges are low and use it during the peak demand period so that we can reduce the peak demand charges. And also it can be used when there is no grid power. And it will also help sustainability, reliability, and the resilience of the campus power grid. And of course, it's going to mitigate the effects of the climate change by generating our own electricity, which won't emit or pollute the air and water. So this slide shows how much energy we consumed in the year 2019. We took 2019 because this is before COVID, and this is kind of more normal. It's about 19 billion kilowatt hours. And the peak power demand was about 4 megawatts. So peak power demand is the utility company, they keep track of how much power is being consumed for every 15 minutes. And then they charge based on the peak power demand, that's about 4 megawatts. So our cost of electric utility was about $1.2 million per year. And then this keeps going up at the rate of about 10% as Duke Energy keeps increasing it. All right. So the current study that we did so far, that can generate about 4.6 million kilowatt hours. That offsets about 24% of our campus energy consumption. It would cost about $2.5 to $4 million per megawatt of installed solar. And again, this number is debatable. It keeps coming down because of the market. And the total cost would be about 15 to 25 million. So again, we are looking for funding from external agencies so that we can meet these goals. So with that, I will hand over the presentation to Corey.
Hi, yes. So I'm Corey McVeigh, one of the student researchers from this summer. And talk about a little bit, as Dr. Murthy mentioned earlier, there are a wide variety of options for different renewable energy sources, but we primarily focused on solar energy for a variety of reasons, especially with its abundant, there's lots of access to solar in this area. We can put it on buildings, on parking lots, and it's fairly reliable, whereas wind, for instance, we don't really have a great area to put wind turbines or space for that on campus necessarily. And another group of great benefits to solar are the lack of noise and air and water pollution. You're not burning any sort of fossil fuels, and there's no need to transport any fuel or anything like that. Solar also might have lots of upfront costs for installation and all of that, but down the road, depending on the specific system, there are lots of savings to be accrued for the electric utility bill. You're going to be paying less to supply campus with energy. Next slide. Here we have a nice little graphic of what a solar photovoltaic or PV system can look like. This is a grid-tied solar system, kind of on an average home, for instance, and shows you that when the power is produced from the solar panels, it's coming out as DC power. And to power most of the appliances or things in an average home or say in a dorm room, you have to send that through an inverter to transform that into AC power to power, for instance, a washer dryer or a television as shown in the home there. Next slide. And this kind of outlines a bit of what I was just saying with that image. The solar panels produce that DC power, and it has to be transferred for a lot of those home appliance uses. One thing that can be thought through as well is when the solar, or as we're moving forward and trying to add more electric vehicles to our fleet, that can help with EV charging stations as well, which is a big connection there. Next slide. So what Leif and I focused on this summer was a feasibility study for campus and installing kind of theoretical projects on a lot of campus buildings and a few parking lots. So we were able to use the Aurora Solar software that is actually used by a lot of industry professionals to do virtual studies of what a potential system could look like and what the production would be on a given roof or in a given location. So this image here is shown, that's our system on top of Mills Hall, which is one of the residence halls on campus. And you can see it actually has one of the awesome tools that is a part of the Aurora suite is the irradiance tool. So you can see there's kind of a map of different colors on there, and that's showing the different levels of irradiance or solar production capacity, the amount of solar energy that reaches the specific areas of that roof, depending on how it's facing. South-facing roofs are the best there. And as all of these things are listed on the side, we have also LiDAR is an awesome tool included as well, which can provide different heights for trees and for building roofs to better estimate how much solar energy is going to be reaching those sites. And then there's some very preliminary cost and return on investment estimates included in the program as well. Next slide. So the next few slides will be talking about the results from the study. Then the next slide. Here we have a preliminary timeline that we've kind of suggested for buildings on campus starting next year. As Dr. Ormsby mentioned, we are working on installing solar on the Ollie Reuter Center building. And then these are our suggestions for a rough timeline of some buildings on campus based on the roof type and age, and then the size of what the system would look like based on our research from the summer. With the rooftop solar, we focused with the results that we'll show primarily on the total output in kilowatts of the system, and then the estimates for annual energy production, kilowatt hours per year. And then a very rough estimate of what the cost would look like, as well as an installation year there. Here's a map of the buildings that we looked at. So you can see the top left there is the Sam Miller complex. All the way down to the center bottom there, you can see Highsmith Student Union, which is another big one. And I won't go into what all of the specific buildings are, but that gives you a rough idea. We've kind of looked at most of the large buildings with large areas of roof space to install some panels. Here's a kind of the estimate table from our research. This shows the main buildings that we looked at over on the left, starting Woods Welcome Center here is Chestnut Hall. And then all the way through, you can see the Sherrill Center and the Health and Wellness Center as well. So going from left to right, you can see lots of numbers to soak in, obviously, but we looked at the size of the system in kilowatts and then the estimated energy production annually. And then the percentage is an estimate of what each system would offset from the total campus energy consumption. And we did base that off of 2019 values due to COVID-19 and that kind of affecting the data from those years. So those are fairly rough estimates, and this is still a work in progress, as Dr. Morthy mentioned. There's lots more to be done, and these are preliminary feasibility study numbers. So then we have just a very rough approximated cost there based on the numbers that Dr. Morthy mentioned earlier. Yes, so the next few slides, we have some images that we took from the Aurora Solar program. We've got Chestnut Hall, or the Welcome Center above the Woods Apartments here, and the Student Recreation Center. And just a side note, these little green dots or blobs that you might see on some of the images are actual simulated trees to try to further improve the estimate of what the solar production will look like as trees can block sunlight and affect those numbers. Now, Ramsey Library is here on the left, and then the Highsmith Student Union. And the same numbers from that table are included just by building here, along with the images. Mills Hall and the Sam Miller complex as well. And Sherrill and Health and Wellness Centers and Carpin Hall, one of the big academic buildings. And now I'll pass it off to Leif to talk about the parking lot canopy solar.
Hello, everyone. So the next little section of our research was focused on parking lot canopy solar. This is really amazing for a couple of reasons, but there are some drawbacks. These parking lots provide a large area that captures a whole lot of sunlight, and at this point, it's just going into the pavement and becoming heat, or the cars. So we took the same metrics as this. I will note that these installations will cost a little bit more than some of the rooftop due to the guarantee that you will have to install a racking system or a structural support for the solar panels to actually be installed on. You can go ahead. So we studied 3 different parking lots for this. 2 of the biggest ones up on the top is the Edgewood lot that just got installed, and then down at the bottom is the P1 down off of Campus Drive. We also looked at parking lot P29 as a smaller, maybe less feasible parking lot. Some of these have a lot of shade because we are a very green campus with a lot of trees on it, so some of these are not ideal. These 2 seem to be the most promising. You can go ahead. Here's some of the data. As we've been saying pretty much the whole time, take this with maybe a boulder of salt, because all of these numbers are going to change both with the declining cost of solar panels, batteries, and racking systems. But all of the energy is going to change as we progress as a campus and as the technology gets better. Here's a little name card of the lots. Preliminary numbers again. And the next section is going to focus on the possibility of a campus microgrid. I will note that we have a lot of these infrastructures in place, and installing this into the campus is really just a way to increase efficiency of the components that we already have, interconnecting everything. Good. So what is a microgrid? Taking everything involving energy. So starting at the point where you're using energy, a building has lights and security systems and heating and cooling systems that need energy and electricity to be powered. You then go up the line and you have the distribution center where energy is decided where it needs to go. And then you go to the source, either from Duke Energy, solar panels, or a diesel generator. These can work in tandem with a regular grid, or they can work on their own as an independent system. So what are the components of a microgrid? Pretty much as I just said, a distribution control system, energy generation and capture, such as solar panels, fuel cells, diesel generators, and then storage. Storage, people usually think of electrical batteries, and this is great because it is needed, especially in the context of solar capture, where your energy is electricity. But this can be converted into other different types of energy, such as thermal. If you think about a building, you can actually heat and cool this and store energy in that building until using it later. So why should we actually implement a microgrid? A big reason, and Dr. Ormsby mentioned this before, is the increasing natural disasters, the ever-increasing natural disasters that we are facing. Just at home here, we saw a lot of flooding, and we've been seeing this for the past couple hundred years as well. It's not going to go away anytime soon, so we need to figure out a way to become resilient and possibly prevent the loss of life or our facilities. We saw a lot of storms in the last year that resulted in communities losing power, and this can be prevented with the use of energy storage systems that do not allow for large grid surges to take out communities' ability to heat and cool, and also just simply cook their food. Good. Another reason is maximum utilization. So solar capture is generally maximized between 9 a.m. and 2 p.m., but the campus draw seems to be outside of these areas for the most part. So if you do not have a way to store this energy and then distribute it, then it's going to be lost. So this is necessary to take full advantage of your system. Another is peak saving. Before we mentioned our peak demand charge, this is actually quite significant because Duke Energy scales their charges and adds nearly up to a third of the campus energy bill is due to this charge. We already implement some of these techniques when our campus building automation system sees that we are approaching a peak load. It actually reduces the thermostats across campus wide by a couple degrees in order to save energy. This is crucial because, like I said, upwards of a third of the campus energy bill is massive, and that's direct savings on top of the energy that you're producing and feeding back and offsetting that bill. Right. So you might have noticed that we only analyzed about 8 buildings. This is about half of the buildings on campus, and then 3 parking lots. So this leaves a lot of other buildings, parking lots, including the parking garages that we need to study and simulate. This also has led us down the path of thinking about alternative installations such as ground mount, agrivoltaics, and study areas. We have one green study session area over right beside the Ramsey Library. We call this the Brain Forest, but I think it has another name. And we've been considering the option of creating these areas, but focusing on the intersection between solar technology and green living. Other things that we need to consider before we go further on this research is rooftop structural analysis. We need to see if these roofs can actually handle solar panels as far as weight and structural capability. We need to look into some future component research. Just in the time that we have conducted this research, we have found that the cost of solar panels varies quite a bit depending on the scale of your installation, the type of panels you're going with, and the people you're buying them from. This is guaranteed pretty much to go down in cost over the next couple of years, and which is in our benefit as the cost of fossil fuels is going up, and then also our microgrid analysis and design. So in conclusion, implementing a solar-based campus microgrid promotes all of our current goals as a campus. It encourages interdisciplinary research, because I approach this from an engineering standpoint, which is extremely technical and based on the actual hardware. But this is only one facet of what goes into this. There are financial analyses and many other ways that people can work on this. And this can get the whole campus involved on promoting a carbon neutral future. This also directly saves energy costs in the form of a environmental output, and as well as direct dollar savings. And it provides a resilient infrastructure so where we do not face large scale detrimental impacts from natural disasters. And of course, it's environmentally sustainable in terms of the electrical generation. Some references. Thank you to, of course, our faculty advisors, Dr. Murthy Muthukrishnan and Dr. Allison Ormsby, and the Critical Services Microgrid Group. Please contact us for further questions. We're definitely looking for more people to work on this, and this is a big project.
Thanks, Leif. I will also just mention a couple of other things that are going on. We have a campus master plan that is currently being finalized. And so a lot of our decisions have to align with the master plan. And then I also just want to give a little shout out. I run the McCullough Fellow Program, which is a summer applied research opportunity about sustainability. And I'll be recruiting new fellows in December and January. And projects like this are really great McCullough Fellow projects. And in fact, we're looking for one about EVs for next summer. So if you're interested, or you know a student who might be interested, please contact me. All right, I think we're at the time for open discussion. So thanks, Sol, for putting a lot of resources in the chat. That's wonderful. And does anybody have any questions?
Actually, Sol has very good suggestions. We'll try to follow, because he's the microgrid expert. And he has designed a microgrid at Hot Springs, 5 megawatt microgrid recently. And also he's the designer of the solar PV on Candida building in Georgia Tech. So he's got a lot of experience. His company has a lot of experience. We are trying to work with them and learn from them.
We would love to have a building like the Candida building.
Right.
Or even a smaller scale like the NC State Solar House. We'd like to have a demonstration building sooner rather than later. So we aspire to be like that. Other thoughts, ideas, suggestions, questions? Don.
The city has just recently, I mean, I guess it's been a year now, gotten actually bids and solid numbers for the cost of doing rooftop solar on the city buildings. Mm-hmm. And they seemed a bit lower than the cost that you're using. I think I was something like, now this may be DC energy, but it was $1.75 per watt or something. I mean, if you do a rough analysis, I think that solar is basically free other than, getting the initial investment because the payback is sufficiently fast.
The payback.
Absolutely. I'm sorry.
Oh, go ahead, Leaf.
Oh, so absolutely. And what we found is a lot of this depends on the scale of your installation, and then and pretty much that's like the main thing. We did see prices. It seems to be averaging around $2.25, but this is going down as we speak, and it really depends. But yes, I agree. I think all of our numbers are overestimates. And even in the time from when we put these numbers together, we've seen direct decreases in technological costs.
Yeah, so, I can put solar on a residential house for $2.25 a watt.
Yes, but you're not having to go through the state construction office. So I will just put a caveat out there that our process is way more complicated than a home or even the city of Asheville. So we are constrained by the UNC system policies, and our process for getting it on the Reuters Center has taken, over a year, and we hope to have it installed by February. So there are a lot more hurdles that we have to go through as a state school than a homeowner would. And so we're grateful to Buncombe County because our partnership with Buncombe County has paid for the feasibility studies for 3 buildings on campus: the Reuters Center, the Sam Miller Complex, and the Sherrill Center. So at least now we have estimates for those buildings, but we have to do more detailed engineer plans. We have to get approval through the state construction office, and all those steps add costs. So yes, our price is higher than all these other prices.
System-wide would be a much better deal. I mean, all the universities in the system are going to have to do it. There might be some cost kind of cutting for doing a system-wide.
Or if we had done all 3 buildings at the same time, we would have saved money. Yeah, there are definitely economies of scale. And I know Walt has some creative financing ideas. So we're looking forward to talking with you more on that. But yeah, doing it piecemeal costs more. And if we were able to do all 8 of these buildings that you've assessed, we would save a lot of money actually. And we have to, so I think Corey mentioned, we have to look at like the roof age, the roof type, standing seam versus membrane, the orientation, and the warranty, right? So it may be more feasible for us to do it as the roofs are getting replaced than we put solar on. But yeah, if we tackled the whole campus at one time, we would have such a savings, but it wouldn't be in the same fiscal year. So we're also a little bit bound by our fiscal year situations too. So that's unfortunate because the longer we delay, the more money we're actually losing. But as soon as the energy costs go up, there's going to be even more interest than there already is. Wow, lots going on in the chat. Oh, thanks for the Living Machine info. Yeah, so a lot of these, I'll just talk about Jake's class for a moment. Jake teaches a class called Energy and Society, and we're working with that class to look at these 3 decades, or actually 4 initiatives, and they're doing research. So this information about the Living Machine will help those students. And then in my sustainability seminar class, we're having students develop infographics about each of the decades to try to kind of pitch these ideas. So we're always looking for the curriculum tie-ins, and we appreciate the student effort because that's saving us time and money because we don't have enough staff to actually do this. So thank you, Corey and Leaf, so much. And the microgrid group for acting as unofficial mentors for the students. It's been very nice. One final comment, or I want to thank Dean Holt for being here. That's great. Any final comments?
I have a comment. We should do the solar and microgrid as soon as possible. We should not wait until, let's say, 2030 or beyond, because the benefits we get out of this is going to be extremely good, and we'll get the return on investment maybe in 5 years, maybe less.
Yes, I couldn't agree more. Kelly.
I think that can be backed up by Walt's investment experience and background, that the longer you wait, the more expensive it's going to be. There's more savings to capture getting into the game more quickly, and you'll get to your goals of climate reduction sooner rather than later. 2050 is obviously just too late to do what we need to do.
And yeah, I will stress the resilience piece. I think we should not underestimate our need to be climate resilient. And we could do it with our health and wellness center. So we can think about that. We were a vaccine distribution site. We could do it for Zeiss. If you think about faculty research that are in freezers, that if the power goes down, they're going to lose maybe decades of research. So there are certain buildings in particular that could be hardened with a microgrid that I do think are extremely urgent to do right away. So I'll maybe somebody can put in the chat the community supported microgrid website. So that's a Asheville based, but nationwide. Shout out to Ohio, our CSM group, and then there's a initiative or an idea of having a microgrid study center based at UNC Asheville with a working title of AMICA. So that would be great. It would be kind of like NEMAC, but really focusing on solar and microgrids. So we're in conversations with Dean Holt about that. Okay, so lots of stuff going on here in the chat, more resources. I think we're about at time. Does anybody want to have a concluding remark?
Maybe just to say to the administration of the college that there is a way to do this off books. It doesn't take capital investment from the university. There are energy as service companies that will come in, design, engineer, install, and finance these kinds of systems. So Walt knows a lot about that. And that is really something I think the college should be pursuing in terms of getting this done sooner rather than later.
Thank you, Kelly. Walt and I have already met with John Pierce about that, our financial officer. So it's on our mind. But again, the administration of these things is actually pretty complicated. I don't know. I'm going to ask Jean, is the chat discussion saved? Or would someone like to save the chat discussion?
That's a very good question. I do not know if it shows up in the recording or not.
I'm not sure. This is going to be recorded and put on the library website.
Yes.
But if somebody wants to capture the chat, just copy and paste it into a Word document or something. That might be great.
Normally, it'll be accessible to the host of the meeting. It'll get saved as chat in your local directory.
Oh, protect people. So I'll just give a little shout out. Murthy is in the engineering and mechatronics department. I'm in environmental studies. Corey is an applied math major. So we have, and Jake is also in environmental studies with me. So we have a lot of different departments represented. Oh, and Don Nicholson is physics. So, so that's great. All right. I will manually copy the chat just in case, because I'm not, oh, here we go. Leaf's doing it. Leaf, thank you, Leaf. Perfect. All right. Well, again, I want to thank everyone for taking time out of your busy day to be here. And I look forward to continued collaboration. I think there's a lot of exciting things going on and a lot of opportunity for partnerships. So let's be innovative and at the forefront and get some good press out of this, Hannah. You have our emails, and you can, if you have more ideas or hear about grants, please do let us know, and we'll try to pursue those opportunities. Have a great day.